Tonight's subject is gas. Got gas? I hope not. Not that kind of gas. Go out, get some Gas X. No, we're talking about fuel gas. And this is a for some language clarification here. Here in the United States, we tend to hear the word gas. We think of gasoline, which is the liquid that you put into your car to make it go. And I'm not talking about that kind of gas either. We're talking about fuel gas, as in gaseous state of matter. And that's like natural gas that we think of now, that we use to heat our homes, to cook our food on the stove in the kitchen, to heat your water in your house, that kind of gas. And like I said, natural gas is the kind of gas we use in 2021. And it's the kind of gas that we've used for about the past 70 years or so for that purpose. And natural gas is just that. It's something that we're extracting from the earth that's naturally present, that had formed over many, many, many millions of years from organic material that was buried in the geologic rock strata of the earth. And we can put a well down there and we can get the gas out. And it's comprised primarily of methane, which is convenient because methane is very, it's a very good fuel, and it burns clean, and it works well for fuel purposes. But we haven't always had natural gas, and there aren't going to be many people today who would remember the days before natural gas. But prior to like the 50s here in the US, and I think over in the Great Britain, they went through a process in like the 60s of converting the entire country from this manufactured gas to natural gas. So they actually converted everybody over. And the manufactured gas had evolved probably, there were at least a half a dozen different manufacturing processes to make that gas, using coal mostly. They also used oil to make gas. They used, some places probably even used like wood to make gas. But we're going to concentrate on the very first process that was used to make gas, and that's the coal gas process. So this was invented in I think it's like the late 1700s. So this is a very old idea. And some guys over in England, that's primarily where it originated, had figured out that if you put some coal into a closed container and you heat that container up from the outside, gas is produced, and that gas is flammable. So you could actually take the coal and you could basically bake it, and the gases that are emitted could then be sent somewhere through a pipe and used to run a light. That formed the entire basis of gas lighting for 200 years. And the method that was used is very fascinating from a historical standpoint. And what I'm going to do is, first, we're going to watch this video, which is not mine. It belongs to the video is of the Clitheroe Gasworks in Great Britain, which has ceased operation in 1968. So this was the last of these coal gasworks that was operating in the United Kingdom, in Great Britain. So we're going to watch the first few minutes of this and see what a day's work would have looked like if you had worked at one of these gasworks back in those days. All right, let's just play this real quick. The last retort. So the retort is the name of the furnace that was used to make the gas. A little bit of a pun there. That being their building, they would call the building a gasworks, place where gas is made. All right, so what are these guys doing? There's two men here, and they appear to be working in like the bowels of hell or something like that. So they opened up one of these furnaces here, and this film footage is very low resolution, so it's very, even me sitting here, it's kind of hard to really see anything but blurry images. But they've got this furnace opened up, and that's one of these retorts. Okay, and then there's another furnace below it that they had opened up. And what's going on is the coal, there's coal inside of this retort. And that is sealed from the atmosphere. At least when the door is closed, it's sealed. And then underneath here is the second furnace they call the producer. And that is actually open to atmosphere, and oxygen can go in there. What's happening is the producer burns coke, which is coal that they've taken from these retorts, and it burns it, and it produces heat that actually heats these retorts up. So it's like an oven. So the coal is inside there, and the retort is around it, and it's being heated up, just like your oven in your kitchen gets heated from the gas flame underneath it. And it heats the coal up, and it drives off gases. So those gases are what then are used to send out into the town for people to use for their lights and for their, whatever they're burning it in. And the process here that these guys are doing is they are loading one of the retorts. And what has to happen is coal, after it's been baked, basically turns into just carbon. And they call that coke. C-O-K-E, just like Coca-Cola. And that coke is then taken out, they put it into a cart, and they drench it with water, and they can sell that coke to other companies to use it, or other industries to use it as either a fuel or something like that. The other thing they can do is they can pour the coke into the producer and burn it in order to heat the retorts. But after the retort's all cleaned out of spent coke, they bring in a cartload of coal, and they take their shovels and they throw it in there, like this guy's going to do here. That's the gas burning off that's being produced as he loads coal into the retort. Okay, so now they're doing their second retort. So basically what's going on here is these guys are manually loading and unloading this bank of retorts all day long, and that's their job. So if you think your job sucks, go back in time and, just look at this. So imagine how dirty it is. And one of the things that he did is before you open the door of the retort, you have to light the gas on fire as it comes out around the door, so that because when it hits oxygen in the air, it's going to ignite, and you want it to burn controllably and not just blow up in your face. So that's the what a job as the person at this gasworks would have, what it would have been like. So I'm going to go over here to the drawing board and diagram the gasworks and explain in more detail about how it functions and how it converted coal into the gas that people use to light their homes. All right, so gasworks, gas plant, gasworks, whatever you want to call it. They call them gasworks over in Britain. We probably call them something similar here. But the way it works, you got these retorts, you got these furnaces, these sealed chambers. All right. And back in the 1800s, when the first coal gas plants came online, the retorts were basically a vertical tube furnace. And we're just going to draw the vertical, or I said horizontal, not vertical. So horizontal tube furnace. All right. And the furnace had a cross section like a letter D. All right. So this is what the front hole of the furnace would have looked like if you were looking straight into the end of it, into this end. And there was a door on here, okay, and there was a door that they could open and close. And then attached somewhere near the end of it was a pipe that came out that went all the way up to the ceiling. And the guys would open the door. They toss their, oh yeah, and this thing also is inside of a furnace called a producer. Okay. So it's a big brick box that it's inside of. Okay. And there's another door down here. Okay. Like that. And there's a fire under here. And that fire is fueled by putting coke into the bottom of the producer. So this is being heated up, like just heated up like the bowels of hell inside of here. So basically what's going on is it's heating this retort up, and they load their coal into the retort, and it lays in there, and it just gets baked by the heat from this this producer underneath here. And the temperatures are probably in about 1,000 degrees Celsius. They're quite hot. And so that'd be like almost 1,800 degrees Fahrenheit. And that temperature caused gases to basically volatilize out of the coal. So it cooked all of the volatile matter out of the coal. But the coal did not actually burn, because this vessel is completely sealed off from the air. So oxygen could not get into here. And that's the entire basis of coal gas, is you are baking, they call it destructive distillation, or, I'm just going to use the word baking, because that's what it effectively is, of the coal, and you're gassing off all of that organic matter that's in the coal. Basically everything except for the carbon content of the coal. The raw fixed carbon that's in there. So the gas all leaves and it goes up this big pipe, and it goes up to the ceiling of the gasworks, up to the very top. And the way that they designed the retorts, they call them retort banks or retort benches. And the retort house would have at least one bench in it. And they would be set up in with more than one. So you have, let's just say, one here, one here, one here, one here, and they could have however many high, and then underneath is your producer. So you're heating the retort bank from below with a fire underneath here. And each of these has coal loaded into it, and there's a pipe that comes out of each one, and it goes up, and they'd stagger them somehow so that they would be evenly heated from the bottom. And when one was being unloaded and reloaded with new coal, the other ones were still producing gas. So the time that the coal was in the retorts was probably between 8 and 10 hours, from what I understand. So every 8 hours, the retort would have to be loaded and unloaded. So if you had a retort house with, let's just say you had 8 retorts in your bank, that means that every hour you were loading and unloading one of them. And you could stagger them so that you did it every hour. And like I said, there's a pipe that leaves the retort, and it goes up to the very top of the building, and it ran into what they call the hydraulic main, Okay, so we have our retort bank down here. Just going to draw 3 of them. All right. And a pipe came out of usually they came out of like the corner, the top corner of the thing, and it would go up. And then they would gooseneck down into a larger pipe. Kind of get the idea of what I'm drawing here. So this is a larger pipe here. And we're going to run a line from each of our riser, from each of our retorts, up to this larger pipe called the hydraulic main. And they called it a hydraulic main because it had water in it. And the water was quite important because obviously you're producing gas in retort. You know, let's say you got 3 in your bank, you got 1, 2, and 3, and you got to unload and load, take the coke out and put new coal into number 1. You don't want the fire getting up here and then getting into the other into all the other retorts. You want them, and you also don't want gas backdrafting through here and then getting up into the open line. That's, you got the door open on this one. So they would fill this up with water to a certain level. All right, and this functioned as like a gas trap. So the gas that's coming off of these has to bubble through that water that's in this big hydraulic main. All right, it comes in and it bubbles through the water. And there might be a couple of inches of water that covers the end of this riser that dips down in, and that creates a seal. It also helps to condense out the oils and the tarry substances that are in this gas, because obviously this gas is coming off of here. It's not just methane, or it's not just hydrogen. It's not just some pure substance. It consisted of a whole cocktail of compounds, like all kinds of stuff. All sorts of crazy chemicals were created whenever you would bake this coal. And those chemicals would collect, if they weren't gases at normal temperature and pressure, they would collect in the bottom of this hydraulic main, and the gasworks would periodically clean them out. And there would actually be valuable products that would collect in there, and they would use for various secondary markets. So gasworks produced gas, but it also produced a lot of chemicals. And there was a product called coal tar that they produced. Then there was the coke that came out of the retorts after it was done baking. And the all those things were then sold as products to other users, either for fuel or whatever. So this is your gas or your retort house. So after that, the gas goes through the hydraulic main and it goes out, and now it has to be processed and so that it can be sent out into the pipe distribution network and actually used by the public. So the way they did that was, a few different methods that were used to clean the gas up. And so we're going to have our pipeline coming from our retort house here. Gas is coming, raw gas. All right. Now, depending on the gasworks, the equipment that was used and the order that they placed it may have varied. But I'm just going to kind of do this based upon, what kind of makes sense. So I'm thinking they probably would put the gas through a vessel called a scrubber. And the scrubber basically sprays it down with more water. All right. And often they were fed from the bottom. So we're going to scrub our gas with water. And water is going to trickle down through here. They might have had balls in here in order to increase the surface area. The gas goes through the scrubber, and that takes out the things like ammonia, sulfur dioxide. It takes out water-soluble contaminants that are in the gas. It also removes a lot of just the general dirt that's in there. So we scrub our gas with water. And then there's probably chemicals that are in here that didn't get scrubbed out with the water. I know that some of the gas works would use what they call a purifier, And the way the purifiers were built is they would have a box, often made out of wood, so that it didn't corrode. It was filled up with like iron chips, metal iron filings. Okay, and the iron would react with certain gases like traces of sulfur and hydrogen sulfide and just nasty, generally nasty. Cyanide, I think, was one thing that the purifiers would take out. There was a lot of various gases that were left after scrubbing. They would purify it. And then after the purifier, this is a scrubber. And a purifier. Okay, after the purifier, iron was in here. I think they may have even had like wood chips in some of the purifiers. Like we're talking 1700s and 1800s here. So after the purifier, now the gas, obviously, to get the gas from the retorts through all this equipment required some form of a motive force. So they would have, like, they call it the exhauster. So the exhauster was the pump that moved the gas. And when the gasworks were like this, the pressures that they used were quite low. So by the time the gasworks, it might serve an area of a population of maybe a couple thousand people. A lot of these, especially early on, these gasworks, they didn't serve that many people. So the gas pressure that you needed to distribute through that kind of a piping network was relatively low. And they just used this exhauster. And I'm just going to draw it using a standard pump symbol. But the exhauster was driven by, a steam engine, or in the smaller gasworks, they used an engine that was powered by gas once internal combustion engines became available. Okay, the exhauster increased the pressure of the gas. All right, and then one of the things that they tried to do was have some form of storage for the gas. So if you had a problem in the retort house, if there was an upset in the plant, or they didn't want to build a gasworks that could meet peak demand, you would have what they called a gas holder. So the gas holder, so after the exhauster, our gas is clean, okay, and it's ready to be metered and sent out, and we're going to put it in what's called a gas holder. Gas holders are, if you've ever been to one of these older cities, sometimes they're still there, but obviously not being used. Gas holder was like a tank, a low pressure tank that they would store the gas in. And these tanks were built with it was almost like an upside down can or cup in water. So it had two, containers, and there'd be water in here. Okay, gas is coming from the exhauster, and they blow it into this container. And this volume, basically right here, with this X in it, that's the gas volume. And then the gas can leave, and it can go out into the distribution network. So as the gasworks is producing gas, it's pumping it into here, and then as the consumers are using the gas, it's leaving. And this lid, this whole entire container, which could be hundreds of feet wide, it could be a huge thing, will actually rise up and down with the volume of gas that was inside of it. And the water basically created the seal that kept the gas from escaping. This whole tank would operate at atmospheric pressure. Sometimes they put weights on the top of here if they needed a higher pressure. So they would weight down the lids, and the weights would correspondingly compress the gas based upon how much weight that was there. And that would allow them to increase the distribution pressure out into the network. So you might have, the gas network might run at like, I don't know, 11 inches of water column or something like that. They ran at really low pressures. Today, whenever you have natural gas in your house, the gas comes into your house at 7 inches of water column. Now, they're regulating that down at your gas meter. Back in these days, they often would just send the gas out into the distribution system. They'd account for a little bit of pressure drop in the piping, and there would be regulators for people, you would just get it whatever pressure it was. They would try to keep that pressure steady. They might have had regulators out in the system, I don't really know, but ultimately it's not like natural gas where the transmission lines are running at very, very high pressures. It was all this was a low pressure ordeal. Okay, the gas holder. Now once you're done in the gas holder, they probably had meters throughout various spots in the distribution system. But they would measure how much gas leaves the gas works and goes out into the pipes. And then you had a meter at your house that would tell the gas company how much you need to pay for fuel that month. And that's basically it. So we're just baking coal is all it was. And those D-shaped retorts were the earliest version. So you piled your coal up in here and you baked it from underneath. You had a fire going underneath it. Coke was loaded in there and it baked it. The gas came off, went up a pipe, and it was used, and it was processed and then used. So these hand-fired horizontal retorts, and I may be messing up and calling them vertical instead of horizontal. They were horizontal. Sometime, I think probably in the early 20th century, they started to automate the gasworks, and instead of using horizontal retorts, we went to vertical ones. So the nice thing about a vertical retort is that gravity can be used to load and unload the coal and the coke. So they have a lid up here. There was a machine that would actually open these lids, and then there was another lid at the bottom, or a gate that they could slide back and forth, and the coke would fall out. It would fall into a container that would collect it. And I'm talking hot coke, like 1800 degree coke, fall out. And then they had a machine up here that would reload the retorts and put new coal into them. And it really automated the process of running these gasworks. So you didn't have the hand shoveling of the stuff in and out of the retorts. So that's basically it. It's how they made gas back in the 18th and 19th and early 20th century. How people lit their homes right before electricity, and got the gas to use as a fuel. That's it.